In this video I want to talk again a little bit about inflection point of inflection. If we have some curve like this curve consists of two bends. There is a right-hand bend and there is a left-hand bend. And there is one point that separates the bends from each other. And this point is called the point of inflection. And if we draw a cyclist who is here going up, and then at the maximum point he has so at this point the slope of the cyclist is 0, and then we have here the point of inflection. At this point the cyclist, the slope of the cyclist is very strong, very strongly negative. Shortly before this point it's also negative, but the cyclist is not that steep. And also shortly afterwards the cyclist also has negative slope, but also it's not so steep. The steepest slope is at the point of inflection. And if you remember, the slope is actually just the derivative of a function. So this is the x-axis, and the derivative of that function would be something like this. Here where the minimum and maximum is, because the slope here is 0, the derivative has its zeros there, its roots. And here the slope is very strongly negative, and that means the minimum of the derivative must be at this place. So the derivative looks something like this, a parabola. So this is the original function f of x, and this is f prime of x, the derivative. Next we can make the second derivative, the derivative of the derivative, and here the slope is 0, that means the second derivative must have its 0 at this place, and then it looks just like this. It's a straight line that goes from bottom to top. And what we see here is that we look at these 3 points. So this is the point of inflection, and the derivative has its point here. It is the minimum, the deepest point, and the second derivative must have its 0 at this point. That means if we want to calculate the point of inflection, we just calculate the root or the 0 of the second derivative. That means f double prime of x equals 0. This is what we have to calculate then.